Hello, class. Well, today we're going to be talking about scatter plots. And scatter plots are simply a tool that you can use to, that's right, predict the future. Let's start off with a quick definition. A scatter plot is simply a mathematical representation on a two-dimensional plane showing the relationship between two variables, one on the x-axis and one on the y-axis. Okay, so that sounds, more complicated than it needs to be. All it is when you come, give you an example down here, you're going to have on an XY plane, you're going to have two variables, one on your x-axis, one on the y-axis, and then you're going to have a bunch of dots, okay? So you're going to have one of three different types of correlation. You're either going to have a positive correlation, a negative correlation, or no correlation. Now, a positive correlation is going to be something like this, okay? You got your data, and as you move from left to right, it shows a positive slope. Okay, so you have a positive slope. Okay, to your data. Negative correlation, well, like you would have guessed, okay, kind of the opposite. Okay, when you plot your data, okay, you end up with a negative slope. As you go left to right, it seems to go down. Okay, and then no correlation is just, well, it's kind of all over the place. Okay, doesn't appear to be any correlation to the data at all. Okay, so when you have one of these types of correlations, you're either going to have a positive correlation, a negative correlation, or no correlation. And what they're talking about is if you take a line and you try to get it as close to fitting the data as possible, okay, you're going to get something like that, you're going to get something like that, and this can be almost impossible to draw a line because there's really no correlation to it. And what we're going to do today is we're going to look at how to find the equation of that line, okay, the equation of this line that we just sketched in right here and right here, and use that to make predictions for future data. Okay, so let's take a look at that. Okay, so take a look at our example here. Determine if the data shows a positive correlation, no correlation, or a negative correlation. Well, this is pretty straightforward. Okay, this is actually something that pops up occasionally on your SATs. Taking a look here, if I were to take a line and draw it through this data here, okay, it's going down left to right, so that's going to be a negative correlation. Okay, this it doesn't seem to be any kind of rhyme or reason. It's kind of all over the place. So I'd say that has no correlation. And this, if I take a line, sketch it through there, it appears to be going up, left, right. I'd say it has a positive correlation. Okay. And while we're going through here, I'm going to tell you the secret word for this video is bunny. B-U-N-N-Y. Bunny. B-U-N-N-Y. Okay, now, these lines that I've sketched in here, and here, those are specifically called the line of best fit. Okay, so they're called, the line of best fit. And simply, a line of best fit is the straight line that best represents the data on a scatter plot. This can also be called a trend line. So, like we were talking about before, it looks like my line's disappeared. So if I'm looking at this guy right here, okay, that would be about the line of my best fit. Okay, this is a scatter. We said that was no correlation there. This is a positive correlation. And like with everything else, these can be represented by our old friend, the slope-intercept form. Y equals mx plus b. And we're going to use a tool called desmos to figure out how we can take our data, plug it in, and it's going to give us our slope, it's going to give us our y-intercept, and then we can go ahead and create our equation for the line of best fit and use that to make our predictions. Okay, so example 1, determine the equation of the line of best fit for the given data. So our first step is going to be open desmos.com. Okay, we're going to open a table and enter the data. We're going to use, and this is very important here, Y, the little squiggly mark. Sorry, It should be y1, the little squiggly mark, mx1 plus b. Enter that. We're going to get the slope and y-intercept. And write the equation. Okay. After that, we're going to be able to use it to go ahead and make predictions. So if you're given something like this, one way to do it would also be to do it manually. I'm going to shell out here to Desmos in a second and show you what this looks like. But manually, you're going to end up with something here. So you got -1, 3. You got a point there. Got to turn my little writing thing on there. So you've got -1, 3. You've got 0, 3. You got 1, 1. You got 2, 0. You've got 4, -3. 1, 2, 3, 4. 1, 2, -3. Okay, so if I look at that, I'm seeing something like this. Okay, I'm guessing I'm going to have a negative slope. I'm going to have a y-intercept. I'm going to guess it's someplace around 3. Okay, give or take. But let's go ahead and see what Desmos shows me. Okay, so I've gone here to desmos.com. I'm going to go ahead here, click on Start Graphing. When I do, this pops up. Okay, in the top left-hand corner, I'm going to go ahead and click on the little Add Item. I want to add a table, and I'm going to go ahead and put in all the x1 and y1 values. So for my x's, I had -1, I had 0, I had 1. Whoop, got to the wrong spot there. -1, I had 0. Yeah, -1, 0, 1, 2, and 4. Okay, and on my y values, I had 3, 3, 1, 0, -3. And if you look over here, you can see where Desmos started plotting those that data in on the plane here. You can see that it looks pretty similar to what we had before. Okay, the last data point kind of went off our screen here, but that's okay. So now I'm going to come down here to the second line here. I'm going to put y1. Okay, it automatically gives you the subscript there. The squiggly line, that's usually right. If you look to the left of your 1 key on your keyboard, okay, hit Shift, that's your little squiggly line. M x1 plus b. Okay, awesome. Now, this pops up some really cool stuff here. So it shows here, it gives us our m. Our slope here is -1.27. Okay, it's 2 decimal places, usually pretty good enough. And our b is 2.32. Okay, I'm going to round that to 2.32. There it is. That's our slope. That's our y-intercept. Okay, so if I wanted to go ahead here, I could even say that our equation, y would equal -1.27 x plus 2.32. There's your equation right there. Okay, we have our slope right here, and we've got our y-intercept right here. Desmos made this so much easier to calculate. If you like, you can go and search on YouTube how to do a line of best fit, doing it the long way. It's tough. It's a lot of calculations. Desmos makes this really straightforward. Okay, and our next example, create the scatter plot for the data below, draw the line of best fit. Okay, so if we're going to go ahead and do that, I'm going to go ahead and plot our data manually. Scaling our axes here, looks like I need to get to 200, so I'm going to count these by tens. So 10, 20, 30, 40, 50. 60, 70, 80, 90, 100, 110, 20, 30, 40, 150, and this up here is going to be 200, way up here. Okay, I'm going to count each of these by halves. I'm going up by halves here in some places. So half 1, half 2, half 3, half 4, 4.5, 5, 5.5, 6. Looks like that's plenty far out. Okay, so I know I have 2 and 80, 2 and there's 100, there's 90, there's 80. I've got 1 and 30, 10, 20, 30. Okay, I'm going to go ahead and skip ahead. Your plot should look something like, okay, after you go ahead and plot all your data points, it should look something like that. Okay, disregard this right here. That was, that's a little bit of a mess up there. Erase, erase, erase. Okay, that's better there now. Okay, so this should be what your scatter plot looks like. If I'm taking a look at this right now, this is looking like a positive correlation. Okay, it's definitely going up to the right. I'd guess my line of best fit is going to look something like this, give or take. Okay, now we're going to go over to Desmos and actually get the line of best fit. Okay, so here we are back in Desmos. Remember, I'm going to go hit the little plus button. I'm going to add a table. I'm going to start entering my X values. So my X values were 2, 1, 4, 2, 3, 4, 2.5, 3, 3.5, and 1.5. My Y values to go with those: 80, 30, 175, 125, 140, 150, 100, 100, 200, and 50. Now, before you panic and say, "Oh no, I don't see any points over here." Okay, if you zoom out, look, there you go. There are your points right there. Okay, your points are right there. You just couldn't see them in the other frame. Okay, so now let's get our information for our line of best fit. Remember, we want to say Y1, little squiggly line, MX1 plus B. Okay, now that gives us our equation, or everything we need for our equation. Our equation is now going to be Y equals, here we go, 45.93 x. Okay, so our slope is 45. So right here, 45.93, almost 46. And then our y-intercept is going to be negative 6.7. I'm going to round it to 2, 6.72. Okay, there's your line of best fit. Y equals 45.93 x minus 6.72. Okay, so y equals 45.93x minus 6.72. Okay, if you go to the next page, okay, based on your equation, how many words do you expect a student to type in 5 minutes? Well, that gets a little more interesting now. So now we need to use our equation. Okay, so we're going to put our equation in here. Y equals 45.93 x minus 6.72. Okay, and wants to know how many words we'd expect a student to type in 5 minutes. Well, minutes, our time here, is our x value. Okay, it's our x value. So I'm going to go ahead and plug in 5 for our x value. So that gives me 45.93 times 5 minus 6.72. Okay, And that gives me, when I'm all said and done, that gives me about, well, it gives me exactly 222.93 words. I'd say that's about 223 words. Okay, so you can use that value, you can use that equation to predict how many words that student would type in 5 minutes. Okay, let's take a look at another example. Okay, the Cody Company ran a study on its sales force and learned that the average number of years experience for each sales team was in direct relation to annual sales volume. The data collected is listed in the table below. Okay, so create a scatter plot, draw a line of best fit, write an equation for the line of best fit. Okay, so one thing I am going to switch up here, I'm going to say right here that this is our X right there. I want this to be my Y. Okay, so I'm going to make that one little switch. So going ahead and switching over to Desmos. Okay, again, I'm going to go plus. I'm going to enter a table, enter my X values, 6, 4, 8, 5.5, 3, 7, 2.5. And my Y values, 46, 35, 51, 42, 33, 50, and 30. Okay, and again, you can see all the data right there. If I zoom in on them, okay, you can see how this shifts around a little bit. Again, positive correlation is what we're looking for. Let's get our the equation for our line of best fit. Y1, little squiggly line, mx1 plus b, and there it is. Okay, with that, we can clearly see that our line of best fit is going to be y equals 4.06x plus 20.11. Okay, y equals 4.06x plus 20.11. Going back to our notes here. Okay, so the equation y equals 4.06x plus 20.11. If you hear that noise in the background, that's my lovely wife and my dog Duke making their appearance today. Okay, how much in annual sales did you expect for somebody with 1 year experience? Well, all I'm going to do is I'm going to take 1 and plug it in here for x. So that would give me y equals 4.06 times 1 plus 20.11. Okay, so that's going to give me 24.17 thousand. Okay, I'm going to put a little k in there for the thousand because remember our annual sales are in thousands, so 24,000 give or take dollars in annual experience. In annual sales. How much in annual sales do you expect for someone with 10 years experience? Well, same idea, except this time I'm going to plug in 10 for my x. So that would be 4.06 times 10 plus 20.11. So that gives me 40.6 plus 20.11. That's going to give me about, I'm going to just bring that up over here. I'm running out of room here. Around $60.71 thousand. Okay, in sales. Well, that should do it for your notes. If you have any questions, please feel free to see me in class. Thank you.